Sketch a function f continuous on its domain on a set of all real numbers. Satisfy the following conditions. The condition that we have, the function is negative 8, the function is 0, the derivative at negative 8, the derivative is 0, all equals 0, and also the function value is non-negative. The function value equals 0, it means these are the x-intercept where y is 0, and the f prime at the point equals 0 tell us the horizontal tangent. And the function value is greater than or equal to 0. That means the function value, they all are non-negative or greater than or equal to 0. Let's sketch a graph. Locate the negative 8 and 0 point on the real number line. The function value equals 0 at those 2 points. And the slope is 0 at those 2 points. The function value, they all are non-negative. So the graph will make a turn at those 2 points and remain above at or above the x-axis. So this is one of the sketch graph of this function. This example, we have f prime greater than 0 on this interval, negative infinity 0, 4 to 6, and 6 to infinity. That means the function behaves an increasing function. F prime less than 0 on the interval 0, 4, that means the function is decreasing within this interval. F prime at 0 is undefined, so that means this is x equals 0 is the point of not differentiable. That means either the sharp turn or the cups or slope on the left on the right are not the same. F prime at 4 equals F prime at 6 equals 0. If the F prime equals 0, so that is the point that gives the horizontal tangent or the critical point. Also at x equals 0, we call this another critical point. Let's sketch the graph. The points of interest would be at x equals 0, at equals 4, 6, 0 here, 4, 5, and this is 6, so this is 5. From negative infinity to 0, the graph increasing. 4 to 6, increasing. 6 to infinity, increasing. Between 0 and 4, the graph is decreasing. F prime at 0 is undefined, so that is the point that is not differentiable, or the sharp turn. On the left increasing, the right decreasing. F prime at 4, F prime at 6 equals 0, so those will be the point that the graph turns, or we call smooth turn. To sketch the graph, follow the condition. On the left of the x equals 0, the graph increasing, and then make a sharp turn. Make a sharp turn and decreasing within the interval 0, 4. Have a slope 0 at 4, and back to increasing between 4 and 6, and slope 0 at 6, and become increasing again. We have slope 0 at 4 and 6, slope undefined at 0. So the red curve here is one of the sketch graph that follow these conditions. And here is the better looking one. This example, we are going to use the derivative f prime equals the factor x minus 1 multiplied by the factor x plus 2 multiplied by the factor x plus 4 to determine the local max local min of the function f and the intervals of increase decrease, and then sketch the possible graph. To find the critical point, it occurs at f prime equals 0 for the polynomial. So for this problem, for f prime equals 0, we got x equals 1, x equals negative 2, and x equals negative 4. Next, we're going to use the real number line to identify the intervals of increase decrease. For the negative 4, negative 2, and positive 1 on the real number line for the f prime. And our f prime is in the form of the factor x minus 1 multiplied by the factor x plus 2 multiplied by the factor x plus 4. And we use this to see the product of the signs from these three factors in each interval. For the factor x minus 1, any value greater than 1 will make this factor to be positive. The left side or the lower number than 1 gonna be negative. For x plus 2, the number greater than negative 2 will make this factor to be positive. The number less than negative 2 will make this factor negative sign. For x plus 4, similar way, the number greater than negative 4 will give the sign positive. And the left side gonna be negative as a number lower than negative 4. So then the final product of these three signs for each interval becomes plus sign for the right end interval, negative sign for the interval negative 2, 1, positive sign for the interval negative 4 and negative 2, negative sign for the interval negative infinity to negative 4. With the sign positive negative of the f prime that tells us positive sign the function increasing, negative sign decreasing. So then we can summarize it as the interval of increase would be negative 4, negative 2, 1 infinity, and then the interval of decrease will be the interval negative infinity, negative 4, and also negative 2, 1. And then we're going to identify the local max local min as a sign changing from positive to negative of the f prime. Positive, the graph increasing, negative, the graph decreasing. So then we're going to get the local maximum occur at that point. For negative sign to positive sign of the derivative, that point will give us the local minimum. So then the local maximum occurs at x equals is from negative to positive, positive to negative, negative to positive. The local max occurs at x equals negative 2, and the local min, there are two of them, occurs at x equals negative 4 and also at x equals 1. And next we're gonna sketch the graph negative 4, negative 2, and positive 1. At these 3 points, the slope 0. The graph decreasing on the left side of the negative 4, and then increasing increasing between -4 and -2, and slope 0 at -2, decreasing from -2 to +1, and has a slope 0 at +1, and the graph increasing again on the interval +1 to infinity. So this is one of the sketch graph that satisfy this condition.